Hi guys, this is a video for chapter 10, lesson 1 and 2. So with this chapter, we're taking a look at square roots. Now in our last chapter, we talked about exponents. So like 3 to the second power, we know that that means 3 times 3, which is 9, right? So what we're looking at here is the opposite of squaring something, which is what we call a square root. And so the opposite of squaring something, we would just put this symbol over that number, and that is called a radical sign. So if I say, what's the radical of 9? That's the same thing as saying, what is the square root of 9? And so really when we put this, we're saying, well, what two numbers, when you multiply them, equal 9? And you can think through, well, two numbers that are the same would be 3 and 3. So the square root of 9 is 3. And so I'm going to put up a few examples here of square roots with different signs in front of them. And we are going to take a look at how to work these problems out. Okay, so first one here, square root of 25, that's just a positive number. So we have to think through what two numbers that are the same multiplied equals 25. Well, 5 times 5 is 25, right? So 5 is our answer. 5 is the square root of 25. Now, if we have a negative outside a square root, that really just means -1 times square root, that positive square root. And so we can just do this regular square root on its own and then multiply it by -1. So square root of 144 is 12, and -1 times 12 is -12. So essentially, if you see a negative outside your square root, just bring that into your answer, because your answer is going to be a negative as well. Now we're going to look at a new symbol, positive or negative sign. This means your answer or your problem can be positive or negative. So that's how we kind of explain this sign, positive or negative. So this is saying, what is the positive or negative square root of 49? Which means your answer will be a positive or negative, because if we bring out positive, a positive square root of 49 is just 7. And then a negative square root of 49 is -7, right? Just like this problem. So we have a +7 or a -7. And so when we write our answer, instead of writing two numbers that are the same and then writing either or, we're just going to write our answer as positive or -7. And so you can, again, bring this symbol into your answer. Whatever is outside the square root, you can bring that into your answer. Now let's take a look at this. Square root of -36. Now let's think through this. What two numbers, if you multiply them, equal -36? Well, for a square root, because, what two numbers squared, we're trying to think what number squared equals -36. When you're squaring a number, it has to be exactly the same, right? So, I have 6 times 6, but that's not -36, and I could do -6 times -6, but when I do that, that's not -36, right? Because negative times negative is positive. So really what happens is if you have a negative inside your square root, you have no solution. You cannot solve this. And if you plugged this in your calculator is even going to tell you, sorry, I can't work this out for you. So let's talk about how to work our calculator. On your calculator, you have this x squared button. That really is a power to 2 button. So if I said like 4 to the second power x squared, what I would have on my calculator is x, or 4 to the second power, and then that would give me 16. So that's just a shortcut. Rather than saying your power up with your exponent button, you can just do x squared. Okay. So right above the x squared button, there's a radical sign. To get access to that radical sign, you would do second and then x squared, and immediately you see the little radical symbol. with a parentheses. Then you can put your number in. So if I wanted to find what's the radical of 25, I can plug in square root of 25, and that's 25, right? So if we want to try seeing if we can do a negative square root inside the button or inside the radical symbol, you know, we could try that. So let's say we plug in square root of negative 49 and then press enter. See how it says domain error? It doesn't even work. The calculator is saying, I can't work this out for you. So that is a big hint that you have no solution. Okay, so what you're gonna do on your lesson is basically first writing out the square roots for these answers, and then making sure you put in the correct sign. So this would be, you know, square root of 25 is 5. Square root of negative 25 is no solution because the negative is inside. Square root of 169, if you work that out on your calculator, is 13. And if if you just know that, that's great. This is negative 14. This is positive or negative 4. Okay, so that's kind of how you work out. This would be no solution. And I'm not going to do all of these with you just because I've already done this lesson in class, and I think you guys get the idea. So one thing I would like for you to do is know the perfect squares going from 1 to 17. So if you can memorize this and know this on your test, you will get extra credit, okay? So what we call a perfect square or a perfect square root is when that number square rooted is a whole number, because there will be times when you square root a whole number or square root a number and it's a decimal number, and we'll take a look at that in a second on the back of our study guide or on the second page. So I would like for you to know all these squares from 1 to 17. So 1 squared is 1, 4, 9, 16, 25, 36. Now these are easy because you know this stuff. You know your multiplication table. 64, 81, 100. Now it maybe starts to get tricky, right? 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. This is 225. And then we have 256 and 289. All right, so you might want to screenshot this or write this down, pause the video, copy this, and if you memorize from 1 through 17 and know them all by heart, you will get extra credit. So I think the tricky ones are really from 13 to 17, right? Remembering those. And so you now know, like if I see a square root of 289, I know that 17 squared is 289, so the answer is 17. I think that was one of your problems on your study guide, 289. Where is that? Yeah, number 2, negative 289. So that would be negative 17 as your answer, right? 225, that's one of your perfect squares. So your answer would be positive or negative 25, not 25, 15. Positive or negative 15. 256, I think that was one of them, right? So that's positive or that's just 16. So knowing those perfect squares will help you be able to solve your answers a lot faster. Now let's talk about if we don't have a perfect square. So number 13 through 24, these are not perfect square roots, which means when I work this out on my calculator, I get a really long decimal. So I'm gonna work that out, square root of 8 on my calculator and plug it in. And I get a long decimal, 2.828. 427,125, keeps going. So I'm gonna round this, like the instructions say, to the nearest 10th, and I'm gonna write my answer as 2.8. And I'm gonna put a little squiggly equal sign because that's just estimating close to 2.8. And then I'm gonna do the next one, square root of 115 and that is 10.7 rounded to the nearest tenth. So you get the idea. If there's a negative, keep that negative outside. So square root of 21 is 4.582. So I'm going to round this to 4.6. Make sure your rounding is accurate. Don't mess up on your rounding, right? If it's 4.5825, this 8 makes my 5 go bigger, goes up, so it's 4.6, right? Don't write 4.5. I'm going to be stickler about this. I'm going to check your work and make sure that you're rounding correctly. Now in this section, what you're going to do is just round to the nearest perfect square. So when I'm looking at number 1, I have a square root of 11. Well, I have some perfect squares. Let's see. I'm going to think through what are some perfect squares that are close to 11. Well, square root of 9 is a perfect square. And so instead of trying to figure out what square root of 11 is as a decimal, I'm going to find the perfect square of 9 and round it to 3. So you can actually use your little list that you wrote up here and think, okay, so 11 falls somewhere in between, 9 and 16. So 11's closer to 9, so 3 is the answer. The next problem, like 62, you might look at your work and say, okay, well, where is 62, square root of 62, where does that fall in the midst of all my numbers here? And so 62 is like right close to 64. And so you'd say, okay, square root of 62 would be maybe close to 8. So that would be your answer, would be rounded to be 8. Let me find my, oh, did that go away? Okay, so that would be, your number 2 would be 8 would be your answer. Okay, back to our thing, I found it here. So this would be rounded to be 8. And this would be rounded, the closest perfect square would be square root of 25. So this would be rounded to like 5. Closest perfect square here would be maybe 16, so it would be 4. So hopefully you get the idea where you're rounding it to the closest perfect square root of these numbers. All right, I'm going to move on and take a look at chapter 10, lesson 2. So with this lesson, part of it is a review where we're looking over this real number system, where we kind of break down, okay, your whole numbers, your integers, and rational numbers, which we learned first semester. And so there's even some examples here that give you some examples of what whole numbers would be. Whole numbers are just any whole number from 0 on up. 1, 3, 500, 200, 210, right? Any of those are whole numbers. Now, integers are whole numbers and they're negative. So integers are whole numbers, but including negatives. So whole numbers are always positive, integers include the negatives. And then rational numbers are any number that can be written as a fraction. So 1/8 is a fraction, 0.4 repeating can be written as a fraction, -1/2 can be a fraction. Even square root of 0.64 can be written as a fraction. So any number that can be written as a fraction is a rational number. Now, irrational numbers are numbers that cannot be written as a fraction. So pi is an example, a imperfect square root. So if I square rooted, 26, if I plug that in my calculator, I get this really long decimal that just goes on forever. There's no pattern to it, so it cannot be written as a fraction. That's an irrational number. Okay, so basically what you're going to do here is identify what your numbers are. Is it a whole number, and you're going to use W to represent that? Is it an integer? You're going to use Z to represent that. And then, or is it a rational number? If it's none of those, then it's probably irrational. So you're going to use these letters to represent your sets of numbers. So number 1, 21 is a whole number. Now, if it's a whole number, it's also an integer because integers include whole numbers in there. And then if it's an integer, if it's a whole number and an integer, then it's also rational. So it's all 3 of these. So put every category that it can belong to. Because I could write, 21 over 1, and that would be a fraction. So I could write that as a rational number. Number 2 is just a rational number because that's just a fraction. Number 3 is just a rational number. And then we have -5, so that's just an integer and a rational number. Number 7 is a whole number, a integer, and a rational number, right? 0 is all of the above as well. Okay, and then these are, I think these can be written as fractions, right? So these are rational numbers, and then square root of 5, when you plug that in, it's a long decimal that doesn't have a pattern, so that's irrational. That's your only irrational number. Okay, now taking a look at comparing your number values. So notice here, I've got decimals and square roots and fractions, which means I probably need to turn them all into the same kind of number so that I can compare them well. Now, I don't have my calculator with me right now, so I'm not going to be able to do, well, I do have my calculators right here. So I'm not going to do a lot of them with you, but I'm going to go over 11 and 12, okay? So let's do 12 first. Writing 125 square rooted as a decimal is 11.18, okay? And then to turn a fraction into a decimal, you just do the numerator divided by the denominator, plug that in your calculator, and you get a decimal, 4.09. So when you look at this, 11.18 and 4.09, obviously this one's greater. So square root of 125 is greater. Now looking at 11, be careful with these negatives, because when you have a negative, if you think about this on a number line, -1 is greater than -5. I'm not going up in order, but -1 is greater than -5, but the number itself is smaller, but it's closer to the right. So your number value, if it is a negative number and it's a smaller number value, it's greater, right? So looking at 11, -3 and 1/8 would become -3.125. So you would just add this whole number into your answer, 3 points, and then plug in this part would be 1 divided by 8, which is 0.125. So then you do -3 plus 0.125, and that would be your -3.125. And then square root of 14 is 3.74. Okay, -3.74. So looking at this one is actually greater because it's a smaller number value, which means it's closer to the right on a number line. Okay, so just be careful with that. You've got to be careful that you actually think through what's going on in the values. All right, our final thing is solving equations with exponents, with squares. So looking at number 1, x squared equals 9. I know you guys could probably mentally figure this out, that 3 squared equals 9, so x has to be 3. I'm going to talk through with you the process and working this out and the steps you need to take. So we know that when we solve equations, 2 big ideas that we do is that you have to undo the problem and you have to keep it balanced. Those are like the 2 big key things when you're solving equations. Just like if I did 2x plus 4 equals 16, I would subtract 4 on both sides. I'm undoing it and I'm keeping it balanced. Then I have 2x equals 12. And then I have to undo the problem and keep it balanced. What I do here, I have to do on the other side. So x equals 6, and I can solve it backwards like that. Same idea here. We're going to undo the square to get x by itself. So the opposite of squaring is square rooting. So when we square root, this cancels and we have x equals square root of 9, which is 3. Now, our answer is going to be positive or negative, and that's because if I put in 3 squared, that's 9. If I put in -3 squared, I'm also going to get 9. So really what I realize is my number could be a positive or negative of that same value squared, and I'll get the same answer. So just to be clear, we're going to write our answer as positive or negative whatever the square root is, okay? So this answer here, we're gonna square root both sides, and t equals positive or negative 5, all right? Number 3, let's take a look at that. So looking at number 3, let's get some room and do it up here. And if you do this on a piece of paper, that's probably a better choice because you have more room to write stuff out. So 4h squared equals 144. To undo this problem, we're going to do the opposite order of PEMDAS, which means we're going to divide first. We're going to get rid of the extra stuff with the h, get rid of it, so we're left with h squared. And then we have 144 divided by 4, which is 36. And now we're going to square root both sides. And you have h equals positive or negative 6, because if I plug that in, I could do a negative 6 squared times 4 and get a positive 144. I could do a positive 6 squared times 4 and I get a positive 144. So I have 2 options for my answers, positive or negative 6. Okay. You might do some where you have a decimal answer, like number 5. When you square root both sides, square root of 30 is not a pretty number. And so you're going to round to the nearest 10th, like the instructions say, the nearest 10th if necessary. So this is going to be positive or negative 5.5 about, okay? So that's your answer there. All right, I'm not going to do the rest of you. Hopefully you get the idea of the steps and how you do it, and make sure you write your answers as positive or negative. Now on your homework, I want to see all your steps. I want to see step 1, step 2, step 3. I want to see that you're keeping it balanced and you're undoing the problem. I want to see that your answer is positive or negative, and I want your equal signs to be lined up. So be careful on your homework. Please don't condense it all or just write your answer. I'm going to be really looking for clearly written out work, okay? All right, and that's all I have for you guys.